I mean, not necessarily. Dogs don't. Dog species have never been able to retract their claws. The cats as a species group, the vast majority of them don't retract their claws because they're not pack hunters. They're solo stalking hunters. And so they want to get where they can get to quietly. Like a cat, this is what a cat, like, cats are walk on their, they have their pads. This is quieter than this. Like dogs can afford to make noise because dogs are primarily, and they don't retract their claws. It's not an adaptation they have to have because they are pack hunters. They make up for their lack of stealth through sheer numbers. Cats are solitary creatures, generally speaking. They are not, most of them aren't terribly fast. They are a stalking kind of hunter, and so they need to be quiet, which is why they can retract their claws. That's the reason for that adaptation. So going through the adaptations, we had structural, we had physiological. Structure is how an organism is built. Physiological was an internal response to changing external stimuli. The example that you guys gave for this was changing colors in things like octopus, things like chameleons. Block D gave another really good example of a physiological adaptation. They talked about how different animals shed different kinds of fur as the weather changes. That animals can have different kinds of coats in different weather, in different seasons, is a physiological adaptation. Another one that was mentioned is an adaptation that you guys all have, actually. You guys, as mammals, are warm-blooded. That is an adaptation that all mammals have. Being warm-blooded means that you can regulate your body temperature regardless of what's going on outside. If it's too cold for you, you shiver to raise your body temperature. If it's too hot, you sweat to lower your internal body temperature. So you have degrees of being able to survive depending on the climate, but lots of lizards can't do that. That's why you don't have snakes in the Arctic. It's too cold. They all freeze to death. If you have lizards that need to get warmer, they have to find sun because they're cold-blooded. They cannot regulate. If you have lizards that need to be, if that same lizard species needs to cool down, it has to find shade. Most fish species are similar. Most fish species are cold-blooded. They can only live in climates that they are adapted to, and if there's a change in the water temperature, they will die. But there are some fish species that we've actually discovered are warm-blooded. One example of a fish that can do this is the great white shark. Great white sharks can live in hot temperatures and in much cooler temperatures because they are, Soham, I think you said you had to leave at 120. It's 120. If a great white shark needs to regulate its body temperature, it can. It can maintain a warmer temperature than the ocean around it, which is a unique trait amongst fish. So there was one more kind of adaptation. I've mentioned a good example of it already when Josiah was asking about the cats and their claws. Can anyone give me an example of an adaptation that is neither structural nor physiological that could help unlock this last adaptation category? Owls? Owls, what are we talking about? That would be structural, how they're built. Okay. I actually mentioned this as an example of about why dogs don't need to have retractable claws. Why don't dogs have to have retractable claws? Who was listening to me 5 minutes ago? It's close to sociological. It is sociological. I'll use a simpler word for it. Behavioral. There are behavioral adaptations. Things that animals choose to do, actions that they take, that are adaptive for various reasons. So behavioral, what an animal does. Dogs are inherently social. It's part of their behavior. It's why they do so well with people. It's why they've survived for so long as a species on this planet. They have limitations as far as what they're able to do as predators because they can't sneak up. Dogs can't sneak up on anything. Watching a dog try and sneak up on something is adorable because they can't do it. They are loud creatures. And so they get a group together, and now all of a sudden, a group of loud animals can take down a prey animal much larger than themselves without having to resort to stealth. Other examples of behavioral adaptations, hibernation. Hibernation is a good example of a behavior. When a food source goes scarce for bears in the winter, for example, they hunker down, they eat a ton of food in the fall, they get real fat, and then they hunker down. They sleep for most of 6 months. They lower their metabolism so they don't need to consume a lot of calories, and then they just slowly sleep and get skinny for 6 months. And then in spring, the weather gets warmer, the food sources come back, and out pop the bears, which can be a terrifying experience if you've ever experienced a bear coming out. Like if you've been present when a bear comes out of hibernation, it can be a really cool and terrifying experience. I've known some hunters who have. What are you looking for?
Were you just looking for it earlier?
Yes, the giant ladder. I'm still trying to get that up.
Not a rush, but we were looking for one earlier today and noticed that the
And I don't know where the metal one is. Okay. Where do I need to put the orange one? Who needs it?
Nobody needs
Okay.
it. Brian was looking for one of them.
Gotcha.
I have mine because mine is secret.
Nice. Yep.
There's a lot of
Fair enough. Gotcha. I just haven't got around to using mine and no one's asked about it. Okay. Yes. Being present when a bear comes out of hibernation. Awesome and scary as all get go. Yes. I mean, part of what's scary is actually being physically present for it. You're walking through the bush and all of a sudden a bear comes out of a tiny hole in the ground. That's the issue. Watching it on YouTube, it's just this big sleepy animal coming out of the ground. It's less interesting on YouTube. You can YouTube it later. It's adorable, but not necessary for us to spend time on. Okay, so that is the first principle of natural selection. The second principle is that when there are variations in a species, some of those variations must be favorable. Organisms that have an advantageous mutation may survive better in changing environment. Example, the white bunny versus the black bunny in a snowy environment. We discussed this one a little bit a couple weeks ago, a week ago maybe, when I went through the dihybrid Punnett squares, and I said, you're not going to have to learn this, put your pencils away, we're just going to talk through it. But the very last example that we talked about in there was this idea that you can have recessive traits that are selected in favor of in an environment. And the example that was given was the white bunny. White fur is recessive. Black fur is a dominant trait. But white bunnies are a favorable mutation in environments where there's a lot of snow. Even though the black fur is the dominant trait, the black-furred bunnies will die out. Because I don't know if you've ever tried to find a white object in snow versus a black object in snow. The black object shows up in the snow in a big way. The white object does not. And the only black part on a white bunny is what? The eyes. The eyes are the only black part. Oh, I mean the claws. Yes, we're not going to see claws on a bunny. It's the eyes. As soon as they open their eyes, it's like, for those of you who are aviation fans, the whole point of a stealth aircraft is to decrease the radar section. You want detection systems for stealth aircraft to see the giant bomber as the size of a bee. Functionally, that's what these bunnies are doing. They've shrunken what part of the bunny you can see to the size of a dime in this snowy background, having one little black eye being the only thing that's visible against the white background helps them survive, even though it's a recessive genetic trait. So that is principle number 2, is that some of those variations must be favorable. Flip the page. Another principle of natural selection is more offspring are produced than can survive, and there should be no period, or there should be no blank there. More offspring are produced than are able to survive. So you have a lot of offspring present. And for one reason or another, more are produced than are able to survive in a region. Things like bunnies produce tons of offspring, but not all of them will make it to adulthood. Some of them will get eaten, some of them may starve. More offspring are produced, that should say than can survive. And the offspring that survive have favorable traits. As a result of this, a population will change over time. And you guys saw this yesterday. I broke you up into 4 groups, and I gave you different kinds of bird beaks. There were more of you in every generation than could survive. Every type of beak had organisms that died. But there were 2 beaks that populations managed to survive to the end and thrive. And it's actually interesting because I did the same activity with my D block yesterday, and that class has way more girls in it than this class. And as a result, the level of aggression in that activity was way lower. And as a result, we actually had more birds survive the 3rd generation reproduction than we actually had students in the class. You guys there was 14 of you survived after reproduction. There was less alive than we had students in the class. And in the other block, there was more students that survived, more birds that survived than were in students in the class. And that's almost exclusively because you guys were being overly aggressive. We only had 1 girl die in the other class because she was too aggressive. Evelyn. Evelyn died because she was being too aggressive with the beans. We only had 1 girl in that class die because she was being too timid. We had more die in this class because you were scared of all these guys up front. Yes, but not everybody wanted to get involved. So more of you died because you were too timid. More of you died because you were too aggressive. But one thing that we didn't have in this class that we did have in the other class, I don't know if you guys know Olivia Reimer. She's missed a bunch of class time lately because she fell and sliced her knee open all the way down to the bone a couple weeks ago. So she was a fantastic example. She died every generation because she's injured. She was not able to get down on her hands and knees to eat the food. And I asked her to participate as an example of she was not too timid. She was not overly aggressive. She was injured and could not participate. And it was a great example of a limitation in an organism. Yes, was your hand up? Oh, was there a hand up? I thought I saw a hand up. Okay. So, yes, Luca. Favorable traits? That should be the word than. T-H-A-N. More offspring are produced than can survive. I crossed the line out. That shouldn't be a line. That's not a word. There's no words there, Luca. Yes, Penny. You have a great day. We'll see you tomorrow. Watch the video to get the rest of this lesson. Okay. A population will change over time. So what this gives us is environmental factors. We talked about this yesterday. Environmental factors select for certain characteristics in some individuals and against in other individuals. Fork beaks and spoon beaks were selected for. Those are the populations that survived. The tweezer beaks and the clothespin beaks were selected against yesterday. Those were the populations that died. Over a very long time, the population changes because individuals with favorable traits or favorable characteristics survive and reproduce while individuals without them die. We saw this yesterday. Did anyone die every generation? We had a few of you who died every round. You experienced this because for one reason or another, something about either how you were equipped or how you were behaving caused you to die. Josiah's was first equipment, then it was behavior. Elijah, I don't know why you died. Was it equipment or behavior?
Equipment,
Then probably behavior. Okay. So, this is where we talked about yesterday, selective pressure. The environment exerts selective pressure in a few ways. The selective pressure results from the one that we demonstrated in class yesterday was this one, the last one. Competition for limited resources. Those resources could be things like food, could be space, but competition for limited resources is what we demonstrated in class yesterday. But selective pressure also shows up due to predation. I didn't release any predators into the room. Cats, you guys are all birds. I released a population of cats. Didn't happen. Another environmental pressure is different than competition and predation is disease. Disease is an environmental pressure. Some populations are better suited to coping with different diseases. Some are not. Yes. That says space. Food. The resources we're talking about here are food and space. Someone needs glasses. Okay, so talking about disease, humans are actually a really good example of how disease is a selective pressure, is a selective environmental pressure. There are people in our population that are just naturally immunocompromised due to their own genetic makeup. Their immune systems just aren't as good as other people's immune systems. If the human race decided to adopt survival of the fittest, those people would die very quickly. Because if we adopted survival of the fittest as a human thing, put your phones away, unless you have a really good reason for being on there. There you go. We would just stop treating people medically. If humanity was like, you know what, no, screw this, survival of the fittest, you get sick, you can deal, lots of people would die. I wouldn't be here if we adopted this, because when I was born, my kidneys weren't functioning the way they were supposed to. So I would have been selected against. And so never mind the fact that I would have died. If medical intervention wasn't a thing, my wife and my daughter would both have died during childbirth because my daughter got stuck. And without the intervention of medical professionals, both of them would have passed away. So there's all sorts of things that we do as a human race to actively work against natural selection. But we're a really good example of how disease can impact things differently. And people are impacted differently by the exact same strain of the exact same disease. COVID was a fantastic example of that. I knew friends who had COVID and it was mild. I know people who had COVID that died. It was the exact same strain. It killed some people I know, and it barely affected other people I know. And both of them were either both vaccinated or both unvaccinated. I saw both results. It happens because of variations in a population. You can't look at someone who is vaccinated. Now, my tangent, you can't look at someone who was vaccinated and said, well, they died, vaccination didn't work. Yeah. Because the vaccinations did work for huge portions of the population. No, you stop right now. No, you stop right now. You stop right now. I'm not eating any of the crap in my classroom. It's like when I kick out the flat earthers. Flat earthers, there's the door. Someone always jokes about it during astronomy. When are we going to talk about the flat Earth? Can we deny vaccines? No, you will not be denying vaccines in my classroom. No, the Earth is not flat. Here we go. Keep going. Natural selection is also situational. A trait that may be a disadvantage to an individual one time may be an advantage to its survival later on. And the opposite is also true. What could be advantageous might become disadvantageous depending on what's going on in the environment. So the example that I have here is of a woodpecker. Why does a woodpecker peck wood? No, but why does it have the beak that it has? Sorry? Yeah, to punch holes in trees, eat the bugs. That is the role of the beak on a woodpecker. So make a note on here. It drills into trees. Usually they're dead. To eat bugs. If you can hear them. If those trees disappear or the bugs die out, the woodpecker, I'll zoom in a second, maybe, that's why I'm reading it to you as I'm writing it, unsuitable for new food. If you can't read that, Josiah, you need glasses.
No, I can't. Guys, your head wasn't there. I don't know why he's talking. Because he couldn't read the squiggly line. And I couldn't tell if that was a C or an R.
Focus, guys. I did.
That word behind food is, I thought it was spare. Because it looks like an R. That's obviously spare.
Okay.
And I
Okay, so that's my example. The beak of the woodpecker is an advantage as long as there is wood available to peck. If there is no wood available to peck, or the species of food, like what it needs to eat inside the wood, if that's not available, all of a sudden that becomes disadvantageous. Hey. Okay, let's keep going. Natural selection. So that's natural selection. Period, all stop, 5 points to natural selection. Now, this is where natural selection takes that jump into the theory of evolution. Natural selection, we see it all the time. This is where it jumps into natural selection. Natural selection can lead to the formation of a new species. This is called speciation. Different color. The big example for, I'll explain speciation, I'll do 2 examples on the next page. Individuals of the same species, or a definition, I'll go here. A definition for what makes a species is individuals of the same species can interbreed to produce fertile offspring. This is one example. Sometimes members of a population change so much that they are no longer able to produce fertile offspring with members of the original population. This leads to speciation, where new species are formed. And I'll give you my example here. The example that I'm going to give you is, at some point in the past, there was a a horse ancestor. I don't know what it was. I'm not an evolutionary biologist, but at some point in the past, there was a common horse ancestor that over the course of time and mutation and natural selection and all these things seemed to produce different subspecies of animal. You get further and further down the chain, further and further away from that common ancestor, and now you get to two examples I'm going to give you here, the zebra and the donkey. Mules are another thing. Mules what you get when you breed a horse with a donkey, if I'm not mistaken. So we have what we would call your everyday horse. You've got your zebra, you've got your donkey. If these two are allowed to breed, if a zebra and a donkey are allowed to breed, what they will create is called a zonkey. And a zonkey cannot reproduce. You cannot take a zonkey and another zonkey and breed them together to get more zonkies. It doesn't work. And so what you've reached here is you've gotten to a point where zebras and donkeys definitely related. There are traits that they share. They look like they could be the same animal in some respects. Forget the stripes. But they are unable to reproduce together to produce a viable offspring. The same thing is true if you take a donkey and a horse. You take a horse and a donkey, you breed those things together, you get a mule. Mules also cannot reproduce. Correct? You cannot take a mule and make another mule. Nothing. They can't. They're infertile. And so you've gotten to the point where these are considered different species because they cannot reproduce to create a fertile offspring. Speciation has occurred. Yes, Himparis. Yes.
So, like, is it true that, like, the liger never stops growing?
No, that is not true.
But, like, how come when the liger becomes so bigger than both its parents?
It depends on which was the male and which is the female. If it's a liger or a tigon, and with the kind of tiger that was involved. I don't know if that's always true. I knew they took a lion and a Siberian tiger. That thing's good. Yes, that thing got beefy. I don't know why it's bigger than both. That thing got massive. You're right. But I don't. But Himparis, that was one example. Like it's a rare example. It doesn't happen very often. Well, you can't say mostly and then always.
So, like, because there's always, like,
I don't know. I haven't read what you've read. I don't know. What was the second question? It depends which one's the male and which one's the female. Hey, Josiah and Luca. Josiah, yes? What was the question? That is a viable offspring. I don't know what it is. I'm pretty sure it's viable. I can't remember. Well, you either get a liger or a tigon. Yes. Okay, flip the page. Depends on which one's the male, which one's the female. Okay. Two examples. An example of speciation. We had the zorse. I forgot about the zorse. Or zorses viable? Can you breed zorses? One type of speciation is what's called adaptive radiation. While Josiah looks up zorses. Okay, so same problem. Okay, adaptive radiation. Adaptive radiation is where Charles Darwin was like, oh my gosh, guys, this is it. Theory of evolution. The adaptive radiation is the diversification of a common ancestor species into a variety of different adapted species. Now, there is limitations to the theory of evolution. We don't know what the common life ancestor was. If there was an ancestor for all of common life, it's unknown and unknowable at this stage. But we can look at living species and point them to a common, more recent ancestor. And the example that he used was finches, yes. The number of chromosomes is different. So when you have a horse, I don't remember what the exact numbers are, but for example, if you had a horse had 46 chromosomes, half of 46 is 23. So the sex cells in a horse are going to have 23 chromosomes. In a donkey, it is 44, so half of 44 is 22, and so what you're going to get is 22 chromosomes from a donkey sex cell, 23 chromosomes from a horse sex cell, which gives you 45 chromosomes, half from mom, half from dad. 23 and 22 is 45, and you can't take half of 45. So the mule can't undergo mitosis because you need an even number of chromosomes to split. I don't know about all, but I know the ones that are related to horses, that is the case. That's the reason they're infertile, because they can't undergo meiosis. They can do mitosis, they can't do meiosis. Okay, adaptive radiation. The species is, or the bird is called a finch. And there's a ton of different species of finches on the Galapagos Islands. And what Darwin noticed was that all of these finches, they do share common traits. They were related. They all came from a singular species of finch off the mainland of Ecuador, because that's the Galapagos are off the coast of Ecuador. But based on the types of food sources on the different portions of the island, the different finches developed different types of beaks depending on what food was plentiful in their area, and then the traits that were best suited to eat that food. So here's my example. You have sections of the island that the finches primarily eat large seeds, like what you guys did yesterday. They need large beaks to crush those seeds to get out the stuff that's on the inside. There's other parts of the island that the finches adapted to eat bugs. There's other parts of the island where they adapted to sip nectar. And if you look at the beaks of the nectar ones versus the seed ones, it's unlikely that these beaks would be able to crush seeds. It's unlikely that these beaks would be able to sip nectar, just based on the structure of those beaks. And so you had finches that adapted to their food sources in different ways over multiple generations, and so the species themselves changed. And these aren't like individual species that came from the mainland. These were species that were special to Ecuador, to the Galapagos. And so they would have had to have, guys, I'm almost done, I promise. So there would have had to have been a finch species that moved over and then adapted to source all these different food supplies. So I was going to write in what I said there. Finches on the Galapagos Islands have different beak shapes due to the diverse diets. And another example, I don't know why these are the way they are, but tortoises. Tortoises on the Galapagos Islands are all different due to mutations, natural selection, and adaptive radiations in their species too. I don't know why, I don't know how, but those tortoise species are different. Some are big, some are small, some have long necks, some have short necks. Yes, Gemina.
Read it.
No, he just needs to pay attention. You get 3 words. You, Josiah, were being distracted.
Yeah, I just saw it.
And I'm thinking, hey, Luca, right. Maybe if you took out your headphone too. Okay. If a species is unable to adapt to its environmental pressures, it is possible for every member of that species to die, an event that we call extinction. And this is the big issue that we have with climate change now. The climate is changing in parts of our planet faster than these animals can adapt. A good example of this is the polar bear in the Arctic. Polar bears require large chunks of ice so that they're not constantly swimming, so that they can rest, so that they've got a place to hunt seals. They need the sea ice. But as the planet gets warmer, the sea ice is disappearing. And you've got huge chunks of the Arctic where the polar bears there is no sea ice for them to survive on. And as a result, this polar bear species is shrinking. If it shrinks too far, then and because polar bears only have a couple cubs every year, if the population gets too small, and especially if those cubs don't start surviving better, eventually we will lose the entire population of polar bears in the Arctic. Imparis.
How come the polar bears are the biggest fish?
I don't know. That's a great question for the polar bear.
So, if it's like mutation, I'm trying to Google it because I got mad that everyone called like tortoise a turtle. It says all tortoises are turtles, but not all turtles are tortoises. Does that mean?
So a tortoise is a subspecies of turtle.
Yeah.
A tortoise is turtle is the overarching species, and you have lots of different kinds of turtles. You can have sea turtles, and you have turtles you find at Fish Trap Creek, and you have tortoises as a subspecies of what we call turtle. That's what that means. Okay. That is it. You do have a turtle. It's just a special turtle we call a tortoise. Okay. Flip the page. This is where your homework starts. And I would like you to do all of the questions from here up to the page on artificial selection. Artificial selection is this page way the heck over here. Where you see this title, that is where you stop. I do not know why polar bears are the biggest. I just know that they are, and if you breed a polar bear with a grizzly bear, you get the adorably named Pizzly bear, which is even more terrifying. Yeah. The Pizzly is a thing. It only happens to my knowledge, it's only happened in captivity, because or in northern, and maybe rarely in northern Manitoba, because that's the only place on the planet. Oh, northern Russia as well, because those are the only places on the planet where they both exist.